One of the big questions with respect to Greenland ice sheet and sea level is how much of the meltwater actually escapes to the ocean. And a very large amount of the meltwater that melts every summer on the surface of the Greenland ice sheet does not flow into the ocean. It percolates into snow layers and refreezes there. And that's what we're studying in this project, trying to get a handle on that. Like, our knowledge about this process is very much informed by models. So there's a huge lack of studies in the field documenting changes to how much meltwater percolates into the surface of the ice sheet and freezes there. We did in this project, we had this drill that can drill into the surface of the ice sheet, where it's not actually all ice at this point, because the ice sheet is formed by snow that's been compacted over many years. So what we're collecting with these ice cores are fern, actually. And because it's not yet solid ice, water can percolate into it, and then it will refreeze at a certain depth. We want to see what is the spatial variability of meltwater refreezing in fern, like how thick are the ice layers that are being formed, and at what depth are they being formed. So when we pull up those cores, we document really carefully. We measure the density, but we also record where do we find these ice lenses, and how thick are they, and what depth are they. What's really amazing about some of the sites that we're visiting is that other people have been there before. We have two sites where there was an expedition in 1989 and an expedition in 1998, and they retrieved similar cores and also documented density and stratigraphy and presence of where the ice lenses are. And so we can compare our cores with their cores collected 20, 30 years ago. I've already done a preliminary analysis of this data, and we can see huge changes in the amount of ice that is stored in the upper layer of the fern. All over the Arctic, climate is changing much faster than the rest of the world. In fact, when it comes to temperature increases, it's double the global average. So the consequences for the people living in the Arctic is going to be a lot more severe than many other places. Greenland right now is one of the main drivers of global sea level rise. A quarter to a third of the sea level rise that we see right now is because of melting of Greenland. And that's going to even become more problematic in the future when melting increases and sea level rise becomes even higher, unless we as a society do something to stop this.